Welcome to an interview with the Next Platform. I'm Timothy Prickett Morgan. It takes a considerable amount of engineering to bring a server family based on a new CPU and a new platform, especially if the server maker has to provide various kinds of differentiation to expand their share of the market into being. In recent years, Inspur has certainly been able to radically expand its share of the server market. Some of that is due to its strong presence in China, but it is also its growing presence around the world, and because it can bring its engineering to bear and volume economics at the same time. Today, we're going to talk a bit about that as Inspur rolls out its M6 server platforms based on Intel's just announced Ice Lake Xeon SP processors. We have representatives from both Intel and Inspur on hand. And let's start by having you both introduce yourselves. Rongshen of Inspur, tell us a little bit about yourself.
Yeah, I'm a Rongshen. Thank you, Tim, for the invitation for this interview. So I'm responsible for the so-called general purpose server product line division, and basically it covers everything end to end, from the product planning to the development stage, through the manufacturing, then later on the go-to-market part. So everything end to end kind of thing, and not only the domestic one you mentioned about rapidly growing locally in China, but also we are growing our presence in the globe as well.
Your growth is crazy. Let's be honest about it.
Thank you.
I'd love to ask you questions about how you're doing that and how Power and Intel all come together in that, but we're not talking about that today, so forget that.
Okay.
Now let's talk to Anurag Honda of Intel.
Hi again. Thank you for inviting me as well. I'm Anurag Honda. I'm the Vice President, General Manager in our Cloud and Enterprise Solutions Group, and I lead a team called Strategic Customers. So basically, serving and supporting our key strategic customers, as well as all of their ODM and OEM partners.
So you're both basically heroes. Like, you're the easiest people in the world to talk to right now because of all this growth. So let's start with the Ice Lake SP processors and their Whitley platforms. Give me three things, and I'll let you each talk here. Give me three things that make this a significant upgrade and that are going to drive value for server buyers. That's what I really care about, in the end, and that's what they care about. What's really important here? Ron,
I'll get started.
Oh, you can go first. Sorry.
Yeah, okay. So Ice Lake is our third generation processor, scalable processor, and we're delivering a wide range of SKUs, which are I would say market optimized SKUs or customer use case optimized SKUs. So the three things that I really feel like as we're launching Ice Lake that I want to highlight is, first of all, it has 46% performance on an average from our previous generation processor. So that's a significant jump. Second is it has
and frankly, it's something that we've all been waiting for. This is something that's overdue. Let's remind people of that, because it means there's competition in the market again. That's a big
so yes, and second of all, there's a lot of key things that we've added on top of what already existed. It was our AI feature. So our AI feature, Xeon, is the industry's only CPU that has integrated AI accelerators built in with our Intel DL Boost technology, and that's given the use case of Ice Lake, it's going to be all the way from the edge to the cloud. And as AI is becoming pervasive, it's going to be a key differentiator and a value add for our customers, and it's actually helping deliver 74% AI performance. AI inference performance improvement over our prior generation. And on the third element of it, and which is going to be key as we go into sort of this new era of the computing that's happening with the 5G AI and the cloud infrastructure being so pervasive, is security. So we're very proud of the fact that we've added two key security features. First is our inline crypto features, and second is our software guard extension, which are SGX. So inline crypto is going to be helping accelerate the overall performance of, I would say, encryption intensive workloads. As everything is getting so secured, we got to be encrypting it. So the performance of that through the features that's enabled within Ice Lake is going to be very useful and valuable to many of our customers from the cloud.
And they don't have to offload it is the point. They don't have to buy an extra thing.
They don't have to buy. Yes. And the second is our on the security side is our SGX technology. So we had this technology in our Xeon E product line prior to this, but we've added this in our Ice Lake generation. And this is, I would say, it's one of the key game changers from a security perspective, as it's a hardware level security that you can actually create enclaves and be successful in like confidential compute and use these features to really make sure that all of the security threats, like you can actually really protect all of the security threats using SGX. So those are the three things that I'm just excited about as we have launched our Ice Lake platform.
All right. Now, Ron, do you have the three of the same things, or do you have three different things?
Yeah, more than three actually. So for this generation, because I mean, we've been working on this one for relatively longer time, because we have more time, right? And actually, I'm not sure you heard about that or not. We have like four, like design philosophies for our like server designs, and basically it's like how we can really have like a breakthrough innovations in the system design, and how we can really, we so-called a precision engineering kind of, approach to make sure the things are really optimized. And the third one is, again, the security is, very, key pillar of the, stuff, right? Last one is the openness kind of thing. So for this generation, if we talk about three things, I would say first one, definitely it's like some breakthrough like innovations we put in. For example, we added like a 32 E1.S rulers into our like 1U form factor, like a 2 socket, two-way, servers. Because cool. We do find a lot of people asking for, high speed storage, right? Without, compromise on the performance side. So we did that because this is, such a small like server space, how we can really put the 32 rulers in without, compromise too much on the CPU power side, right? Heat dissipation kind of stuff, challenge kind of thing. Mm-hmm. And then the other one I tried to mention that is the so-called the precision engineering thing. We put like a specialized waveguide. With that, we can actually help the server to work under like an ambient in a temperature by like 1.5 or 2 degree Celsius degree kind of stuff. So basically temperature can be up a bit. So that by doing so, the data center, people can operate the data center with a higher like ambient temperature. Somehow this is lower the like cost or lower the bill on the air cooling side. So that's a critical thing. Yeah, the other thing, if I really try to mention, is like security front, right? Because this time we put like a so-called dual BNC dual BIOS chip kind of redundant kind of design. Because although we have like in the past we have like dual image in the BNC chip kind of thing, in order to make sure everything's secure. Right? But we do find that nowadays with more and more like 5G, edge computing kind of deployment, right? And more and more like a remote firmware upgrade kind of thing. And because of certain reasons, there's sometimes the broken during the process. Then sure. Funny thing, so you cannot like have the control or contact the server remotely. So how we can really have like a standby chip, right, in the system. Once the main chip, if the main chip is like broken kind of thing, the standby one will like kick in immediately. So we can still get a hold of
you have thousands or 10,000s of things in the field and you can't get to them easily.
Yeah.
You want to have redundancy at that point.
Yes, that's the thing we try to like to emphasize, to help people like basically have a peace of mind, right, later on. So because the service deployment is not in a big huge like large data center, it's actually remotely somewhere physically. It's not hard, it's harder for people to get access immediately. So that's the whole point. So I didn't mention too many because this is a top reason I tried to mention.
It's fine. We're just talking. It's fine. So that leads me kind of to the next question. So, value and differentiation is the name of the game for all server vendors. So, qualify, and if you can quantify, how much differentiation can you really bring to bear? How much value, how much of what Inspur is selling is volume economics, like, hey, I buy a lot of stuff, that means I can get it to you for cheaper. And how much is we really know how to, cram as much stuff in 2U, 4U, 1U, or blade or whatever. What's the differentiation amongst the differentiation? How much of what you do is the engineering and how much is just being big?
Yeah. So Tim, this is actually a really good question, because if you look at the server players, the people will talk about differentiation kind of thing, right? Definitely. And scale of economy, economy of the scale it's the thing, right? So people are talking about. But within Inspur, differentiation, this word is not allowed in this company. Mm-hmm. The big boss said, we are not trying to just differentiate ourselves from other our competitors. Our job is really to satisfy customers' needs instead of try to position ourselves somehow different from others. So we are not talking about differentiation. So the big boss said, no, that's not the way we're drive the business. So I'm sure you heard about the JDM model. You probably heard about that for Inspur. We're doing that. And actually today here in Suzhou in China, we had a big so-called IPF event, Inspur Partner Forum, so annual event. We have one big CSP customer on the stage to talk about their collaboration with Inspur. And they mentioned about the beauty of the JDM things. So basically, we are not simply take the RFP, RFQ from customers. So we just respond to your asks. Basically, we actually, you can imagine, so this is to our customers, they have extended R&D team at Inspur. So this is very close a collaboration. So when they ask for something, we will check why you try to have this one, what kind of things you try to achieve. And by understanding that, we probably have a counter proposal. Say, if you want to really achieve that, probably that's not the best way. We have the other knowledge, because from our other practices, right? To tell them how we can do that one. So this one really if you talk about differentiate, then that one really differentiates us from our competitors. So it's really about early days close collaboration on the product definition, then on the product development kind of thing. So it's then later on, even on the manufacturing side, we're not just and finish the design and move to the manufacturing stage, and then we tell me how many units you want, right? We just build it based on your schedule. Not that way. Basically, they will do the quality control together. They have their own way, customer, they have their own way to measure their quality. So it's not standard one. So basically, we copy their whatever. So then we talk about. So if you try to control that, probably this is the other way, a better way to do that, right? So there's a lot of close collaboration from early ideas all the way to the deployment, to the maintenance in the levels. Up and running, they have to maintain those servers, right? And how we can really have the we call it pre-alert on the defect or whatever is the fault of the components, whatever is under the memory side, in the hard disk side, or the add-in PCIe cards kind of thing. So really, nowadays the CSP person told us to say the accuracy of the pre-alert is up to 95%. It's a huge deal kind of thing. So that ones I would say let us can become so big, and we can in China, if you look at the numbers, we are have more than 50% of the share of total CSPs in China. Bigger ones even big kind of thing, right? So you can think about that way. Then on the other side, the supply chain kind of power kind of thing, definitely yes, it adds value as well, right? Because of the scale, so we can relatively for us can have better supply, relatively better the prices, right? Kind of thing that you can imagine that that's normal practice for this industry. But I would say it's not about that one only, because it's really about for the to us it's early access to the new technology. That's critical thing. I mentioned the E1.S, Lunar SSD kind of thing. It's not about just put a 32 Lunar inside the 1U space. It's because this Lunar SSD thing, the heat is much higher than the regular SSD.
Yes.
And how you can really manage that? If you without the early access to that technology, then I'm sure you cannot find the best paths to the cooling stuff, right? Kind of thing. So I would say that one is adding a lot, because this is basically, if you're working with Inspur, means you have the access to a lot upstream like a value chain kind of thing, and make sure the stuff, the design is using the latest technology, right? It's a more mature kind of thing. So that's a lot like value to our customers. So I just put it this way.
I get it. Anurag, talk about the partnership, between Intel and Inspur. Give us a little bit of background on it. How far back does it go, and how has it changed over time? I mean, I'm assuming it's a much richer collaborative arrangement now than it was a bit back. But give us it from Intel's perspective.
So Intel and Inspur actually have been collaborating, cooperating, designing, actually helping work on platforms for over 20 years. And our focus has been mainly on the data center, servers, storage, AI, and building key solutions, making sure the products that are being used and platforms that are being designed that are high quality and they meet the customer needs overall. As we've gone through our journey, it was initially it was like as a new relationship overall, but as we got to know each other, as Inspur brought more talent as well as experience in building some of these new capabilities, we started actually, as Rong just mentioned, looking at future innovations and future technologies that what can we be looking at for the next generation of level of products. So it got more and deeper, and then. And as in one of your questions, you asked how do we make sure that, hey, the products, the use case becomes different. So how are we collaborating, making sure it's a compute optimized platform or a storage optimized platform or an AI optimized platform. So our sort of our breadth of our engagement actually just I would say just increased just based on how the market was evolving, how our customer base was evolving, as well as just the new players from the end customers and the usage models came in. So it's been a great partnership, and we look forward for further next 20 plus years in going deeper and deeper and wider as we go forward.
All right, let's talk about some hardware before I get iron deficiency here. You've got a new M6 generation of servers. M5 is the prior generation, but the customers who are going to be more likely to replace machines are really probably going to be on M3 and M4, the earlier generations. This is often the case because there's a 3 to 4 year cycle out there amongst the hyperscalers. So compare and contrast really roughly, like how is this one, how much better is it compared to the prior generation? And then for those customers who are most likely going to be upgrading, like what kind of deltas are we looking to comparing to those older machines?
Yeah, Tim. So for this one, so I put it this way. So for our customers, basically, if you look at those guys, two parts, basically, mainly two parts. First one, the customers, they have like set up a new business, and that they basically the existing server capacity is not enough, so they have to add more, right, kind of thing. So you can imagine that no matter it's a new startup or even the like a big guys, they have a new business setup, they will do that one. The other thing, they basically I would say is a existing business, like business expansion, and for that part, it's basically could it be either today's server performance is not good enough, like you mentioned that the M3, M4 kind of thing, right? And then the other one is I would say this is like expand business, there are more customers. They basically try to add more services, not just like a replacement buyer kind of thing. Right. Now, the point I try to make is that we're not in a position try to put convincing existing customers, say, hey guys, your current server probably is not good enough, right? You it's better for you to refresh to the latest one, right?
Yeah, I mean, if you're gonna add inference to your workloads, you can't do it on that old stuff. If you want it native on the CPU, and it's not like inference like crazy, if you have a little bit of inference in your applications, you need something more like this. Absolutely.
Yeah. So basically, just our major efforts is still like try to meet, because there's a lot of customers they are talking about in expansion, and so basically we're talking to customers who made a decision to buy the service. It's not to say I have no plan to like refresh my server, then I have to talk to you, tell you the new like features, new performance, whatever things it's better than what you have in hands, kind of thing, right? We're not doing that kind of like inference or education, so how good it is, the latest one, right? We're not doing that one. Basically, we're talking about the guys, the customers still like they already made a decision. We try to have new service.
Well,
we're
that
working
seems
on
pretty
that.
ideal. You don't have to
And
convince
for
them
the
to buy.
moment,
You just got to stay there. You just got to show up.
yeah, I mean, it's not sure. I mean, basically, we are not like because I used work on the client side a lot. And for the client and PC stuff, you have to tell a lot like a refresh story. For the installation basis, why you need to refresh your PC to the latest one. Because probably for the video conference kind of thing, right? You can tell a lot of stuff in your higher resolution pictures in the editing thing. So we are not talking about that. For the business, at least for the server space, for the moment, for this, I would say foreseeable 2 or 3 years, we're not like need to put a lot of effort to convince customers you need to like refresh that one. But like in the big CSP customers, why they have like you mentioned 3 to 4 years of cycle kind of life cycle thing, they actually have their own measures. How easy for them to maintain the existing server nodes instead of having new one. So they have all the calculation. The performance wise, whether it's good enough or not. So they did that by themselves. So we don't need to put in data over there.
Right.
So,
they know what they want. You just have to take the order and hope you can fulfill it.
Yeah, now basically what's the challenge basically is you should buy M5 or M6. And with the newer generation, definitely the price will be higher than the M5, right? So you can imagine. Then the other thing people are concerned, they're concerned about the stability, compatibility kind of thing. So whether it's compatible with my existing like application stack kind of thing, whether it's good and stable enough, whether it sounds like just I can up and running whether it's stable or not. So we are doing a lot of job from that front, and from M5 to M6, there's bunch of I mentioned earlier, some like several good things, right? But the performance itself is like Intel's data is like 46% general speaking, and our own did the test, our own test that's like a Ceph one. It's like roughly latency drop like I remember it's like a 40-ish something. 40% drop in the latency.
That's pretty good.
And the TPS thing is up by 46, 47, something like that. So pretty in line with the Intel's data. And look at no matter, this is like for the Ceph fund. If you look at the MySQL, those are like an open source database, kind of similar level kind of performance increase. Although the like dollar wise, price wise is up a bit, but somehow people they do the calculation. So that's why nowadays actually customers are chasing us. Say, hey, when you can have the products, for us, and we are waiting for that. So that's another. But for us, we did a lot like a compatibility like test, at Inspur. So we actually do our like own job. So we based on the like historical shipment, right? What kind of add-in cards those guys using, right? What kind of like HDD capacity those guys prefer, right? What kind of SSD those guys are using, kind of thing. So we did all kinds of different like combination. So we did the test and then make sure everything's everything runs smoothly. So make sure people can take it in easily. So that's the whole point.
All right, I got one more question, and then we all got to get back to our day jobs. This is my day job, but anyway, the days when you could just have a tower server and a 1U server and a 2U server and just make a zillion of them, or although it wasn't that many, it's probably a third of a zillion back in the day, are over. This is complicated now. You have to balance all kinds of different compute and storage. You have to balance what the workloads you think you're going to have and how they're going to change over time. This is a very, very difficult time. Now, the other side of it is we've never had so many different kinds of compute and networking storage. So it's a cornucopia of wonderfulness from the engineering standpoint, and it's an application prediction nightmare. So given that, I'll start with you, Anurag.
Go ahead.
What's your advice here? How do people negotiate? And because the server lines are broader and deeper, so how do you help them decide what they need? Because this is hard.
So I think you bring up a good question, and this is something that we have actually worked very closely with our end customers as well as our OXM partners on this front. So if you look at just from an Ice Lake perspective, we have a very broad skew of Ice Lake chips itself. So they're just general purpose. And then we've optimized for 5G, we've optimized for a cloud, whether it's a public, there's slightly different needs
And that's very helpful. I mean, it's annoying to us who have to build tables describing all this stuff,
yeah.
but
that's based
that
on the
helps.
customer. Yeah, so we've actually done a very thorough job with our customers in trying to understand their workloads and trying to make sure when we look at the SKU stack as they're building an Ice Lake, it's actually optimized for a certain side of workloads as well as some general purpose, because in some cases, you don't know what the workload's going to come, and that's why some of the hardware acceleration that we've added, whether it's our AI features or our security features, which is going to be so pervasive everywhere out. So we've done, first of all, we've done some of that work at the SKU level, making sure that we're optimizing the SKU based on the I would say history of information we have with
so we could have a simple rule though going forward. It could be something like this. I'm making this up on the fly. Start with the CPU and then figure out when it doesn't work anymore by itself, right?
Yes,
because
yes,
now the CPU can do enough, right?
Yeah.
It's got some AI acceleration, it's got security functions, it's got encryption, and then if you have to CPU when you can, offload when you must. All right, I'll make it simple.
Yes, and then we've also actually done a lot of work on the software and system and the software level side of things, in which we are actually helping our customers out to make sure that they're getting best out of our products as well. So in Intel's level of software built up on top of our products is actually significantly increasing over every generation as we've added some of these things, some of these new additional features or differentiated features as we talk about. And then as you just not only look at the CPU level, as Ron just described, and as you were also just talking about it, is we actually look at, we just don't build one platform. It's a storage optimized platform. It's an AI optimized platform. But a lot of the building blocks and the baseline features happen to be very similar, and the focus on quality and focus on just making sure the different types of workloads that can go even at a platform level, and how you service it. Like everyone's data center is slightly different. How they want to service it is different. Where they want to have their I/O ports are different. So some of that flexibility is many of the OXMs providing. Same thing, Inspur has been providing that to their end customers. But that requires, like I would say, maybe a commonality of design and certain derivatives that are being created, but leveraging all of the goodness that is provided overall. So in conjunction with silicon, platform flexibility, software pieces of it, we do believe that as the customers look at it, they actually have if they understand a lot more about their workloads, they can choose that one. If they don't, there are also very general purpose roadmap products as well as roadmap platforms that the customer has a ability to choose from. And as they get maturity in their workloads and they get a better idea of it, we work with them in tuning some of their workloads on that product, as well as for the future generation, we can actually guide them better.
Gotcha. All right, Ron, you're going to get the last word here.
Yeah. So yeah, I'm thinking about that. That's actually really good, question, because in the industry, probably they would just follow the routine practice, right? They try to do the tall thing, be in the rack mount thing, and whatever kind of thing. So you can see a lot of different form factors. We have 1 year, 2 year kind of thing, and then we have a so-called computer, focused, server node. We have the storage focused node, or the multi-node, or even the rack scale designs kind of thing, the cabinet design. Now, I'm not trying to do that. I'm thinking about that way. So actually, you're right. We actually look at the customer's needs. They're acting trends. For example, AI is being everywhere. People are adding more and more AI capability into the systems. So usually we have for our a mainstream, 2 socket design, and basically we have 8 PCIe slots. We think it's good enough because people cannot add in 4 GPU cards into the system and remain for too much, too many.
Yeah, it's too much. Yeah, it won't work.
No, okay. Nowadays, people say, okay, 4 GPUs is not enough. I try to add 8 GPUs into one system. So we have to increase the PCI slots to 11. So you can leave the space for other, adding cards. So you can capable of adding that. The other example is basically, we increase the so-called SSD versus HDD ratio, because this is a lot of in-memory database, whatever kind of thing. People want the cache, size is bigger. And we used to have 1 to 6, so kind of thing. So we have 4 SSD slot versus you can do the math. It's 24 HDD kind of thing. Nowadays we do the like you can add 8 SSD over there. So 1, 2, 3 thing, still the 24. And so this is like a kind of thing. So you have the like big range for you to like manipulate for your own use. Last one I tried to mention that is again, so the like open compute. We embrace the open compute, like in a big way. It's no matter it's like the standard, the initiative, like in China, we call it ODCC, which is Open Data Center, like consortium or whatever committee kind of thing. And the other thing is OCP. Definitely you know that one, right? So we really follow the standard, because there are a lot of people, a lot of customers around the globe asking for those like open compute kind of designs, because they can have like exchangeable designs for their needs. They don't want lock into one like a specific vendor, right? Kind of thing. And
well, that only took 10 years, but it's starting to happen finally.
Yeah. We're seeing more demand, because it's not only the big guys, the smaller guys say, you know what, we are looking for high density. We are looking for like the flexible resource pooling kind of stuff, right? We are looking for like a higher like energy efficiency kind of designs. So easy maintenance kind of thing. So we're adding that. So really we try to adapt to customers their needs or their new like application needs kind of thing to serve their such kind of a requirement.
All right, I'm going to have to wrap it up there. Gentlemen, thank you so much for talking, and I'll talk to you both soon.
Thank you so much, Tim.
Thank you.
Have a nice day.
Thank you. Bye.
Bye-bye.